Hey everyone, how are we doing? I feel like I'm slouching right there. How's everyone doing? I've got some more coffee, got a little bit of food. Who's here and what do people want to do? So like this. You gotta sit up. Is my chair all the way up? Yeah, chair's all the way up. There we go. Who is here and what questions do you want to do? Are we streaming? Hey Layla, good to see you here. What questions do you want to do? Canvas Content Quiz 3, that's the first vote. Let's go take a look at some Canvas Content Quiz 3. Remember, we do it by the votes here. So whichever one you want to do, we can work on that. Let's see right here. That's the YouTube Canvas Content Quiz 3. And really great job, everybody. We've got a lot of people doing the work. You know, there's assignments just left and right. I realized here's chapter 5, Canvas Content Quiz 3. Let's do 2 versions of it. We do 2 versions here to practice. Let's go take a look at that. People are saying chapter 5, homework and quiz, chapter 6. I'm stuck on chapter 4. Chapter number 4 quiz question. Which one, Sam? Post it in the chat, Sam, which one you're stuck on, and we'll do as many as we can. We'll do some Canvas content quiz right here. Let's do one version of the Canvas content quiz right now. Then we'll come back and we'll do like Sam and Layla's question. So Sam and Layla, pick a question you want us to do on chapter 5, number 4, number 6. Which chapter you want to do. I'm going to take the first person who puts, hey, Brian, do this question. You put like which question it is because that helps me find it. So here we go. Let's take a look at Canvas Content Quiz number 3. We're going to do one version of it. Let's do this. Just the box plots between 3 classes. You got it. We'll do that one next right here. A test was given to students with a mean of 70 and a standard deviation of 6. Jerry scored a 78. Okay, so what is Jerry's z-score going to be? To find the z-score, what do? The z-score is just the observation minus the mean over the standard deviation. And we're going to talk a lot more tomorrow about how to use this formula right here. So the z-score, see if you can find it. Remember, it's just the observed value minus the mean over the standard deviation. So we always highlight what we're talking about here. This is the mean, which is y bar. This is Jerry's score, which is y. And this is the standard deviation, which is s. Great job, Layla, right there. You got it. Observation minus mean over standard deviation is equal to 1.33333, I think, repeating. And that is y bar minus y over s. We also use sometimes the formula mean minus, observation minus mean. It's like, what am I saying? Observation minus mean over standard deviation is equal to z-score. The difference right here between this formula in green is this is using the population parameters, where the formula in yellow right here is using the sample statistics. More on that definitely tomorrow as we talk about these things. 1.333333 should be the answer. Report to 2 decimals, 1.33. The Chocolate Bomb Candy Company manufactures many different types of candies. Cool. Their most popular Valentine's Day box follows a normal distribution, normally distributed. The z-score can be 0. The z-score can be 0 when the observation is the mean. Great question right there, Layla. The z-score can be 0 when the observation is the mean. Think about an example where when would somebody have a height that is a z-score of 0? When somebody is the what height? It's a really good question. A z-score can be 0. So if somebody's height is the what, they have a z-score of 0. So if we talk about like, what is your z-score for your height? And someone says 0, they're just saying my height is the what for the height. So if someone says my z-score is 0, that means their height is a what? The mean height, exactly. So if you say you have a z-score of 0, then you're 0 standard deviations away from the mean. So you have a z-score of 0. You have the mean height. So here we have a normal distributed. Great job, Sam and Layla. Let's throw some 50 points. We'll start off with some big points right here. This is a great review of tomorrow's topics that we're going to go in depth on. And here we are with a mean and a standard deviation. You decide to buy a box of candy. Your box of candy weighs 457. Calculate the z-score. So here's the observation. So observation minus mean over standard deviation. Let's plug in the numbers. I've got just enough room. We'll zoom out a little bit so I have a little more. Observation is 457 minus mean of 479. It's below the mean, so we're going to get a negative z-score, 16.5. We got decimals this time. So if you notice, the observation of 457 is below the mean. So since something is below the mean, that means it has a negative z-score. because the top number is going to be negative, and then we're just going to turn it into standard deviations. Are you serious? Great job, Layla, right there. Thank you for checking my work. The last one was 1.333, and this one's negative 1.333. So there we go. That should do it. Ooh, people say, how are we going to test these on the test? A very common question is, with these applet pictures, how would you test this on the test? Because you will use the applets for assignments. So this shows you what a test question could look like. In 1992, in the Journal of American Medical Association, researchers reported that a most accurate average body temperature was 98.2, because we usually think it's 98.6, with a standard deviation of 0.7, making the model normally distributed. Now, this notation right here, when you see it, is actually written out capital N for normal. That's the shape of the curve down here. So when you see this, that means the shape of the curve you're seeing. Let me zoom out so you can see it. The capital N just stands for the normal shape of it. And then the first number you see right here is going to be the mean. So here's the mean right here. And the second number is going to be the standard deviation. That's mu and sigma, standing for mean and standard deviation. Now, you might be wondering, well, the mean would go at the center, and the standard deviation would go each 1 unit above. And we'll see this a lot tomorrow. We'll see how the mean and standard deviation are done. The standard deviation is going to be 1 unit up and down each way. It's going to go a unit up, a unit up. I think we can go down just a little bit right here and do this. Again, those are standard deviations. So what I oftentimes do when I get a question like this is I put the mean at the center of 98.2. That's the mean. And then the standard deviation is I'm going to go up 0.7 each time. Like each unit difference I go up is 0.7 because that's the standard deviation. So this is 98.9, 99.6, 100.4. And this would be 97.5. I'm just subtracting 0.7 each time. Now I'm just going down 0.7 each time. I think there might be a question. I saw it out of the corner of my eye. So can the z-score be below 0 if you have a, if it's higher than the mean, it'll be positive. Later, I had a quick question on chapter 3, question 2. Yeah, Sydney, definitely. We're going to do as many as we can. I think we're going to do, what was it? We got a question from, I think it's Sam, and then we have Layla's, and then we can do Sydney's. You got it. Sam, Layla, Sydney. You got it. And so 96.8. We're doing overkill on this problem. We're getting a lot done. And so the 80th percentile. Okay, here's where this problem gets really tricky. This is showing you the 80th percentile. Like this is all information marked on this. What is the 80th percentile? This right here is the middle 60%. If this is the middle 60%, then this is the bottom 20% right here. And this is the top 20% right here. Does anyone know the answer? Because, ooh, this is a tough problem, actually. Because this z-score right here is 0.842, and I'm obtaining that from right here. So this one's pretty tough. This one's pretty tough because, can anyone take a guess what the answer is? Can anyone, just looking at this graphic, can anyone guess what the 80, just take a guess. I don't want you to like solve it mathematically. I just want you to guess with what we've created. Can you guess what the 80th percentile for body temperature is? Just take a guess, and then we'll figure it out exactly. I just want you to guess and see if you have a guesstimate of what the 80th percentile, where this red line is at, because the 80th percentile means 80% of body temperatures are below this. This is the middle 60, so 20% would be on either side, and that makes this right here the 80th percentile, which only 20% would be above. So we used all this information that this is the middle 60 to know that 20% is on either side. That makes this the 80th percentile. What do you think would be a body temperature? 98.7, good guess right there. Somewhere around there, right? So whatever answer we get should be near there. What does the z-score tell us? How many standard deviations an observation is above or below the mean? So we know from this z-score right here, this z-score, that if we take the mean and we add to it a certain amount of standard deviations, we will get the observation. So let's take the mean of 98.2 and add to it the z-score of 0.842 and times it by, well, no, yeah, it's the z-score, times it with standard deviation of 0.7, and that's going to give us, because that's going to be the answer right there. And we have a guesstimate of 98.7. Let's see how close that is. So we're going to go 0.842, which is the z-score, times that by the standard deviation, and then we're going to add that to 98.2, and it's 98.789. And look at your answer right there that you gave a great guess. Let's throw 20 points out there for Quicksilver. Does that make sense how I'm using this formula to say the z-score tells us how many standard deviations an observation is above or below the mean? So I'm just timesing it by the standard deviation to find out, well, I have to go this many because one standard deviation would be 98.9. Just if you do one standard deviation, two standard deviations would be 99.6. So hopefully the visual right here is helping to see the mean, which is mu, that's 98.2, plus the z-score, which is how many standard deviations we are above the mean. We're going to times it by standard deviations to put it back into context. And visually, we're saying, looks to be about 98.7, 98.789 right there. That's a tough one. That's a tough one. It's a lot of information. This is, if you understood this problem, then you understand tomorrow's lecture very well. So this is a great, super tough problem, about as tough as the material gets. Like that's the toughest question I can pretty much ask you on the test. I mean, there's just different versions of toughest question, but that's a level of difficulty I would say is of the highest question. Does anyone feel like they got that? I'll be honored if someone's like, I got that. I figured that out. I know what you're doing, Brian. If you don't, we're going to practice it a lot tomorrow. But guess what? We got another one right here. Dun, dun, dun. It's the final one. Last one's easy. We can do that. Okay, you're ready to do this one. This one looks a little bit easier, actually, because it gives the percentiles. So let's take a look. Let's solve this one. The best way to do this is on your scratch sheet of paper. I understand. Yes, Layla, great job. And you've been working ahead. That's awesome. Take that advice, everyone. Just look over the material. And then when I'm talking about it, you're like, oh, yeah, the mean standard deviation. We got that all. Okay, so here's what I'm going to do is I'm going to use this information right here. It says, what percent of adults have a body temperature higher than this? So you see we have 99.26, which is where this line is. They're showing that this is between 97.14. So let's draw on it. We're talking about body temperatures again. So this is at 97.14, and this is at 99.26. I think this one's easier. You're like, uh-oh, it's one of these really tough problems again that shows us the pictures. But we want to figure out this area right here. I'd like for you to tell me total. What is the green and the blue area total? Let's just put here green plus blue is equal to what area? So this is saying, just using information, green plus blue is equal to what? So the people who have temperatures that are outside of this, those are equal to what? That is a total of what area? You'd be like, whoa, this one was way easier. I like it. Because we're one step away from solving it. The temperatures that are outside of 99.17, which means below that, so the outside area is equal to what? The outside area is equal to what? So what percent is shaded? What percent of this curve is shaded? We're shading people. This percent of observations are being shaded. Exactly, Leila. Great job right there. And one thing you might notice, visually you can see it. Now you might be a little worried, but watch this. This is something you don't have to do. It's visually there for you because we could assume. But watch this, 99.26 minus 98.2 divided by 0.7 has a z-score of, and I'll write the z-score here in red above it, 1.51. That's its z-score. Now, what do you think the z-score is going to be for this one down here? The z-score for this one is going to be observation, which is 97.14 minus 98.2 divided by 0.7. And what do you notice the z-score is for it? What is the z-score for it? And how do those look similar? What do you notice about the z-scores for these? What do you notice about... So this is... Visually, you can see it. Like, you can see what's going on right here visually, which is going to make solving this a lot easier. But what do you notice about the z-scores for them? That's kind of like this one up here. If we were to go down the center of this, this one is as unusually high as this one is as unusually low. They're the same number, just negative. Like this one is just as low as this one is just as high. Like this is just as unusually high. Exactly, just a different sign. So these two areas right here probably are what of each other? These two areas probably have the same, which is not probably, it is true that these two areas will have the same value. So what do you think? What do you think just the blue area would be? If green plus blue is 13, what do you think just the blue area would be? This is the longer solve, because once you figure out the area is this 13%, well, if it's symmetric and you have two things, it's like if I have $13, I'm going to give half the people half the money. So Layla and I, we're going to split $13 right here. I have $13. Hair's going all crazy. I have $13 and we're going to split it. How much money do we each get? Exactly. We each get 0.065. 0.065. Great practice. So each of these is 0.065. In the middle right here would be 87%. How am I getting 87%? Great job, Jessica. 87% is obtained. And make sure during class, if this is the account you want to use, just message during class. I'll make sure to mod you. I always mod people during class, just that way we're on the videos. So 87% is in the center. We've labeled the curve. The last thing I would do, and you'll see me do this a lot on my graphics, is I would put the z-scores below here. And you can see that we accurately labeled the z-score for this one at about 1.51. So I would put my z-scores right here. But that is a complete work of the problem. The answer is 0.065. Good to know every little step, though, and be able to solve them and kind of know the theory behind it. How does a normal probability plot determine if things are normal? So let's go right here, and I'll show you. I really like showing it this way. Watch this. Here is random normal data. How should this histogram look if the data in the histogram, we'll just call it X. How should a histogram look if data is normal? Unimodal and symmetric. How should a normal probability plot look if data is normal? It should look like this. This histogram and this normal probability plot are the way they should look for normal data. So it should do what? Follow a straight line. But what about, I think this will do it right here. Let's just call this Y, why not? How will a histogram look if data is extremely skewed? It'll have outliers and it'll have gaps, and we'll cover this more tomorrow. But tell me, does this look like it follows a straight line now? I'm gonna make it 1,000 observations. Does that look like it follows a straight line? No. This is what's called a normal probability plot. We can do them in jump also. I just like this graphic better. The red line down here is what is normal, like values of y if normal. And this is the normal line. Does this follow the normal line? Yes or no? What do you think? Drink some coffee right here. Do you think this follows the normal line? Would you be like, yeah, that if I asked you to draw along the red line, you'd be like, yeah, that person did a good job. That followed the normal line. That follows the straight line that dictates if something is normal and whether or not we think it's normal from a normal probability plot. What would you say? Good job or bad job to this? You'd be like, you did you'd be like, what would you say? I'd say no. I'd say like, try again. And that's because this comes from a histogram that looks like this. Does this histogram look normal? No. Well, how about histograms that do look normal? Well, this histogram right here looks pretty normal. And you might say, well, wait a minute, it's not perfectly symmetric. I'd be like, well, it looks pretty normal. Let's look at the normal quantile plot for it, known as the normal probability plot. And do you think this person did a pretty good job drawing along the middle line? I'd say, yeah. This is kind of, these little dashed lines right here are kind of like our, yeah, like not so bad. It's not bad if 1 point goes out or a random point or two goes out, because these are outliers. But the more you follow this line right here, the more normal it is. So this is a great example of one that is normal. And then a great example of one that is not normal is going to be something like this right here, which is ridiculous. That is not normal. This is normal. And this is a way to check for normality. So when the histogram is unimodal and symmetric, that is normal. And the normal quantile plot or normal probability plot will look straight. When a histogram is very skewed, you will see a normal probability plot that is very not following a straight line. So the answer to this one is, how does a normal probability plot determine if it's normal? The line is straight, and that should do it. I'm going to be sad if we lost a point. Oh my gosh, what is going on? What did we do? Did I not enter in the decimals? Oh my gosh. What? People are going to go crazy. Wait, have higher than 92 point. Wait. Is this wrong? Oh my gosh. Oh yeah, I need to fix this. Does everyone see what I did right here? I did not enter it in. Can we do the 68, 95, 99.7 rule? Yeah, we're gonna do Sam's. I think it was Sam had a question. I did not enter this in. I need to change this. Please tell me if you got this wrong. Layla, can you or can anyone confirm? Don't want to put you on a spot here. Can anyone confirm that I do give you points back if for some reason you put in a number that it got mad about? Like if you put in the 0.065 and it is 6.5, so that would be the question right there. We'll just get that one right. We'll get a 2 out of 10 now, just for revenge. So here's our revenge right here on the question that we can get it right. Do check the decimals, and please tell me if you get something wrong because of decimals. I will give that back. You obviously knew how to do it. I mean, look, you did all this great work. You're so... I'm just kidding. I was going to pat myself on the back. But yeah, if you get something wrong like that, just tell me. I'll fix it. And I'm going to try to go in. I corrected it in some areas, and then there's just all these little things to correct. There's so many things to correct and fix. Let's do Sam's question right here. Great work on the Canvas content. Great review right there. If you get an 8 out of 10 because something like that, please tell me, and we'll fix it right up. Let's go. Which one do you, after this, Layla, which one do you want to work? Layla, you got the question right after this. Sam had a question. I think it was Sam. We're going to do Sam's question right here. Let me find it. It was... Sam said, chapter 4 quiz question, box plots between 3 classes. Got it. Okay, chapter 4 quiz question, box plots between 3 classes. People are going to be... There's been a few things through my teaching career that students have said that have been really mean to me. And one time in my first year of teaching, I had trouble doing something. Like, my brain just... I don't know. Sometimes things can be tough. And a student looked at me and they said, do you even know how to solve this? And I was like, of course. And they just like, yeah, it was mean. It was so mean. Happy, sad music. Trying to find the box plots between 3 classes. Oh yeah, here we go. Let's take a look at it. This is a fun one. I do know how to do this question. Let's check this out right here. Question with 3 statistics classes. Only the last 2. You got it. Let's check it out, Sam. I swear I know how to do this one. Chapter 5, homework, fuel economy. You bet. Let's do the fuel economy next. So, and then make sure, I think, was it, who was it who had the next one? Sydney. We're going to do your Sydney's question. Sydney, if you want to put your question in the chat, we'll do your question after. Oh, you got it. Yeah. This one's tricky here. And this is going to be a good review because we did this one yesterday too. But don't worry. We're here to do all the ones you want to do. I think the first one's easy because, Sam, you notice that this is extremely what? Something skew. You notice you're like, oh, wait. This first class right here that we're talking about is extremely what skew. You're like, well, that's got a really strong to the low. Look at the little tail, the monster man. He's got a little smiley face there, a little eyeball, and you got your tail right there to the monster man. So you're like, that is very, very, very what skew. Skewed, but what to which side? And then you also notice it over here somewhere. You're like, that's very, very what skew. That's very, very what skewed. It is very skewed, and you are correct. It is C. And it's very, very, as a review also, it's very skewed to the which side. Remember, right to the high, left to the low, whatever way the tail goes. So which way would this be skewed? Good review. Left skewed. Great job right there, Sam. So that's going to be right on that one. But here's where it gets tricky. Here's where it's like, well, wait a minute. How are we going to know between class 2 and class 3 which box plot to look at? And the first time I look at these a lot of times, I am wondering too, well, which box plot is it going to be, this one or this one? Because both of these data sets are symmetric. So you can see the symmetry here that you have about even above and even below. And you can see the symmetry here where you have about even above and even below. But we're talking about class 2. Now, the best way is if you build a sandcastle. You're like, what? Brian, don't ADD on us yet. We're trying to solve the question. If you were to build a sandcastle right here, and we were to talk about where the sand is in your sandcastle, and your sandcastle looks something like this right here. Just imagine that the middle, it's an amazing sandcastle right there. The middle 50% of your sand would be somewhere in here. Does that make sense? The middle 50% of your sand, I meant to draw them on top of each other, would be somewhere in there. But then a mean bully comes over and smashes down your sandcastle to this. They smash it down. They come in and they smash it down. So now the middle 50% of your sand's going to be from here to here. What did they do? They made a larger what to your sandcastle They made a larger what to your sandcastle. It's more what now? It's more what? Just think about the middle 50%. It's more what now? It's more this out. It's more what? It has a larger what. Your sandcastle now has a larger what? Larger middle 50%, which is a measure of the what in the data. You're right. It's a larger middle 50%. And so it has a larger spread. Great job. I figured I could draw it today. And so, Charlie, good to see you here, Charlie. So we're talking about this class right here. Does this class have a larger spread or a smaller spread? Think about the sandcastle example. Here's your sandcastle. Here's your smashed down sandcastle. Does this have the larger spread or the smaller spread? So look at this. Is this spread out more or less than this one? Which one is more spread out across the number line? Like has a bigger spread out, like it's been spread out like butter. You take the butter, you spread it across. You don't glob it up in one spot. You spread it out across. So this one looks more... be careful. This is the concentration right here. Does oh wait, oh my gosh. I thought this was ABC. Sam right there, 20 points. Brian was about to make another error. Sam, you are totally correct. The answer is B. I just had, better not misclick, right? Sam, you are totally right. That is the more spread out. You are 100% correct. Great job right there, Sam. See, Brian makes so many mistakes. So this one right here has a higher concentration of data right here. I hate that they changed. I wish they kept them in order. But the concentration of data in the middle 50% is tighter, and we should do it. Cross our fingers. Not today, my Pearson. Charlie knows that one. One thing we haven't seen a lot of lately is we haven't seen a lot of the quotes in the class. We need to start putting quotes for our class. But we have quotes, and we have like 72 quotes now. I think so. I think things like that. Like I try to always like make visuals and like putting it to things we understand. Like it's more spread out now. Like that's what the IQR tells us is like how spread out the data is. Like how spread out is your sandcastle? Why F in chat Mubot. You can just check out. He's just going crazy. Okay, let's do truth. Did you just randomly say truth? Because I didn't ask him for a second quote. Oh, Charlie did quote 9. Charlie did in the chat. I was like, yeah. People have favorite quotes that they start using after a while, and our class hasn't seen enough of the quotes. I need to encourage. We need to start putting in some quotes. We got to like, when someone says something funny, we got to put it as a quote. So that way we can remember it. Can you go over the chapter 5 part 2 quiz? You bet, Jessica. I think that's kind of what. Let me go back here to space so we can put a break in the video. Pepperoni Pizza Club. Oh, were you in that class that we had the Pepperoni Pizza Club? I think that might actually be. That would be fall last year was Pepperoni Pizza Club. There's a whole bunch of quotes. Layla asked chapter 5 homework part 1, and then Jessica, we can do that one next. Thank you, Jessica. We're gonna do Layla's question right here. Chapter 5. Let me make sure I get it. Chapter 5 homework part 1. Okay, cool. Chapter 5 homework part 1. I'm gonna put a little music on. 80s fun music. Turn it down a little bit here. Chapter 5 homework part 1. Awesome. Let's do this. Let's have some fun. Here we go. Chapter 3, part 2. Sydney, you got it. Here, we'll do Sydney. I think, Sydney, you would ask about that. Sydney, yours is next right here. So let's take a look at this question in the background. Okay. So what is the 68, 95, 99.7 rule? So what the 68, 95, 99.7 rule tells us is 68% of the data will be within 1 standard deviation, 95% of the data will be within 2 standard deviations, and 99.7% of the data will be within 3 standard deviations. So I always go up a standard deviation each time and down a standard deviation each time. So let's see what they say the standard deviation is. It's 7.2. And so we want to find one that goes up and down 7.2 from the mean of 24.8. So they all have 68, 95, 99.7. But this one right here, let's see, 7.2. This is too small. It's very small on the screen too. I don't think you can see it down there. Can I make the screen bigger? There, you can see it. This is not going up and down 7.2. Yeah, Simran, we can come back to that if you want. This does not go up and down 7.2. This is wrong. This was the answer B, and it is wrong because it doesn't go up and down the right amount. This one is also wrong. It goes up and down too much. Do you see how this does not go up and down 7.2? That's not a distance of 7.2. So this one right here should have a distance of 7.2, which is the standard deviation, And yes, that goes up 7.2 and down 7.2. And that's the standard deviation, is how far things deviate. So that should be correct right there. So now, let's continue on. In what interval would the central 68% of automobiles be found? So 68 is within how many standard deviations? 68 is within how many standard deviations? When we're talking about the middle 68, that's within how many standard deviations? The middle 68% is plus or minus how many standard deviations? Remember, it's 7.2. So the middle 68% is within plus or minus how many standard deviations? So it goes 68, 95, 99.7. So the middle 68% is within, exactly, and that's the answer, within one standard deviation, which is just down 7.2 and up 7.2. So we can use the answers right there. So, and thank you for putting in the chat. That really helps me with putting in the answers, because then I don't have to like go between. And all we're doing is just going up and down one standard deviation, and the graph does it for us. Should be right. Now here's where it gets a little more difficult, I think. What percent of automobiles should get more than 32 miles per gallon? So this is where it gets tricky. 32 is right here. Let's draw on this. Let's copy it, and let's draw on it. Thank you, everyone. Really great office hours today. Lots of questions. Okay, so here's called the inside-outside trick. This is the inside-outside trick. 68% is inside of here to here. 68% is inside. So I want to know if 68% is inside, I want to know total what is outside. Be very careful. I'm asking total what is outside. So what is total outside? Total outside is what? We're saying total outside. If 68% is inside, what is total outside? Like 68% of area is all of what's inside of here. That's all 68%. And then total outside. Total outside is what? Oh no. No one else has said a bad buffer yet. We had a weird disconnect during class today. It might just be you, Charlie. I hope. I hope. If 68% is inside, what's total outside? It is symmetric. 32. Great job, Charlie, right there. So what's one of these arrows worth? So we want to know this arrow right here. This is the arrow we are interested in right here. We're interested in this arrow right here. So what is that arrow worth right there? If both arrows add up to 32, what is that one arrow worth? Great job, Layla. What's up, Clay? So good to see you. I just keep getting longer and longer hair if you haven't seen Clay. One of these days I'll cut it. I'm going to ask Chelsea to do the man bun tomorrow, though. That's the goal. So good to see you here, Clay. I wonder how you found it, Clay. Just like, it was like all of a sudden it just appears and you're like, go see Brian, which is awesome. 20 points. Clay, if you haven't seen it, we got the point system and everything. Mewbot is here. Mewbot's chilling out in class. We got a class mascot and everything these days. What's up, Mewbot? It's just, our class just keeps evolving. So it's 16% because it's above one standard deviation. Between 32 and 39.2. So our last graphic's really going to help us out with this. Our last graphic, we got all the Word documents too. Here's where it gets tricky. Here's where it gets a little more difficult. Is watch this. See you later, Clay. Thank you for swinging by. You can swing by anytime you want. What percent of area is in between here? What percent of area? And so now we're going to talk about, this is where it gets a little trickier. What percent of area is in between here? Because we're interested in this right here, which we will find in just a little bit. What percent of area has Brian highlighted in yellow? Only focus on this yellow area right now. Only focus on this yellow area. Just on the yellow area, which is given to you. 68. 95. Great job right there. This is 95% of the area. So we're talking about the yellow area is 95. Total, what is the green area? Total, what is the green area? And be practicing these, be drawing these. The more you practice, the more you draw them, the more it makes sense. What is the green area total? 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 5%. Great job. That's exactly what we want to see. So the green area is 5%. That's the total in the green area. So what is one of the green arrows worth? Because they're symmetric, so they're evenly distributed on both sides. Great job, Sam and Layla. So what is 2.5 each? Exactly, just cut it in half. You'll see, we'll be doing a lot of this tomorrow. Like, we'll be practicing a lot of these. So what do you think is the area from here to here? What do you think is the area from there to there? The amount of area consisting in there. So if there's 2.5 from here over, and there's 16 from here over, then the area between these numbers would be what? The area between these numbers would be what? It's just saying from here over there's 2.5, from here over there's 16. So that means, well, I mean, you'd have to be able to, you know, this has to be the difference between them, right? 13.5, bingo. I'm going to show a graphic right here. Let me go grab the graphic and I'll put it on the screen for a huge help, which I will show tomorrow. Let me show the easy graphic. There's a whole bunch of graphics people create for this. I can't find the graphic. I love it. Oh, found it. Okay. Let me go grab this graphic real quick and bring over here this screen. This screen right here, this graphic that I'm about to show you. Let me put it on that screen with it. This graphic right here basically answers all the questions. Does everyone notice if you look at this graphic down low, and I'm trying to size them to the same size, the area we were looking for is this right here. And so I do know all these numbers in my head, the 0.15, 2.35, 13.5, 34, and then it's symmetric across. But the 34 is just half of 68. So those are the extra numbers right there. Those are all the numbers you would need to know. But we were able to find that using the empirical rule numbers. And if you add up these numbers, you would get 68, 95, 99.7, and 99.7 leaves 0.15 out on either side. So this graphic down here, which I'll zoom in on so you can take a screenshot of if you want, shows you all the numbers, and we were just looking between a standard deviation of 1 and 2. So you could put your z-scores down here of 0, 1, 2, 3, -1, -2, -3, and you'll notice that's what's going on right here. This is at the mean, this is 1 standard deviations below, this is 2 standard deviations below, 3 standard deviations below, and that's what we're talking about right here in the graphic above with how many standard deviations we are above and below. This is a main topic of tomorrow. So 13.5. And describe the best 2.5% of cars. Can anyone tell me, looking at this, the best 2.5% of cars... Oh, we opened the new document. I think that's the problem. Can anyone tell me the best 2.5% of cars would start where? Just look at the graphic I drew. The best 2.5% of cars would be where? The best 2.5% of cars. I should mute myself when I'm eating. The best 2.5, exactly. Exactly. And the best 2.5% of cars is at 2 standard deviations above the mean. So that's 2 standard deviations above the mean right there. So 39.2. Great job. I'm just going to lose track of the quiz. 39.2. That's got it. And great work. Great job, Layla. I hope you're finishing up on this assignment. I think, was it Sydney had the next one? So what was the next one? Simran has one. Sydney has one, right? I think Sydney's first and then Simran. And please tell me if I get things out of order, especially help out with classmates. If you're like, hey, wait, Brian, I think it was this person, but I think Sydney's next. Chapter 3, question 2, part D. I'm confused on how the graphs are made. Let's take a look at that. Here, I'll hop back to space real quick. And thank you, Sydney and everyone. People use these videos, as we saw in class, to help out, to work on the assignments, and just seeing as many examples as possible. I heard a really great math teacher. They said, don't work one problem, work as many problems as you can. Chapter 2, question 2, part D. Okay. So it should be, the rain, no rain. Remember this one. I'm confused on how the graphs are made. Great question. Okay, so let's do the rain, no rain problem. Let's talk about it here. Let's go take a look at the rain, no rain. So we'll start off here. We'll do it a little bit quicker. We did this one, I think Monday. I think we did it Monday. So check out Monday's video for a much longer thing. I'm going to go kind of a little quicker and talk about the graphs at the end. But we did a much longer example of this one on Monday's video, on Monday's office hours. I think that was Monday. But let's go and talk about the graphs here at the end, because that's the main question that Sydney wants to know about. So when we look at this problem, let's first understand what we're looking at. You wake up in the morning and you are going to look outside and see what is actually going on. So on these days right here, it actually rained. On these days, it actually did not rain. But also, the night before, there was a forecast. As in, the night before, you heard the forecast, and they forecasted rain. The night before, you heard the forecast, and there was not rain. Now, these are different days when you hear this. So I'd like for us to look at this specific combination right here, and I want you to tell me, what happened on that day? It did what? Now, be careful which way the arrows point, but I want you to tell me, you can say, Brian, it did this. It whatted on that day. What did it do on that day? What did it actually do on that day? What did it actually do on that day? What actually happened on that day? On that day, it did this. This happened. It rained. So we see that right here by going down on the actual. So it's saying that it actually rained. But the night before, we heard the forecast, and the forecast told us what? Sydney, you're doing a great job. And Leslie. So it told us, I'm so happy to see you, right? Like, yes, officers. They told us what? We listened to the forecast last night, and they said, tomorrow it will. We woke up and it rained. But last night on the forecast, we heard, tomorrow it will not rain. Great job. They said, tomorrow it will not rain, because this is in the not rain group right here. So we're like, wait a minute. They said it would not rain last night, but it actually rained today. This is an error. That's not good. There's another error over here. We'll circle it in red. Yeah, I know, Leslie. I was like, yeah, you're a former student, right? That's why I was like so excited. Let's give, so good to see you, Leslie. Thank you for swinging by. I was like, I love when former students swing. I really mean it. Like, I was like, I'm pretty certain. Leslie, do you remember the rain, no rain problem? This is like the first hard problem. And I truly mean this. And I think I told Layla when we were working this problem, I was like, this is the problem people are going to wonder about. This is the rain, no, it's the classic problem. So great questions right here, Sydney, because some other people are probably wondering about it. These days are the days the forecast was correct, where they forecasted rain and it actually rained. They forecast no rain and it actually did not rain. This day right here, they forecasted rain and it did not rain. Leslie, thank you so much. Like, and you can hang out as much as you want. Thank you so much. I really like students coming in giving. What advice would you give students, Leslie? If you want to throw some advice to students right now. Leslie can show her points right now if she wants. She's probably got crazy points, but unless I reset after so many, like I'll reset. I didn't reset for mini term. Probably have to reset for the summer. But and so Leslie, if you ever come back and you're like, hey Brian, former student, give me my points back, I'll do that. I know we need to like get to these high tiers of points. Yes, Leslie is at Stat Nation Brian tier with 34 hours of watch time and almost 12,000 points. That is completely awesome. Great job, Leslie. So like, and if you want to give advice to students, like say like, hey, do this, this is how I was successful. All for that. Okay, on what percent of days did it actually rain? So there were 29 days here it rained, 7 days here it rained, 36 out of 365. So because we're just adding together the days that actually rained, 365 days in a year, 9.9%. 9.9. Did we get it right? Woo! On what percent of days was rain predicted? So rain was predicted right here on 29 and 64. That's when rain was predicted, the forecast. Divided by 365, 25.5. On what percent of days was forecast correct? Not that I know the next question. But on what percent of days was forecast correct? That's when it actually rained and rain was predicted, or actually no rain and rain was not predicted. So 29 plus 265 divided by 365. We're just adding together this number here and this number here, dividing by the total 365, and we get 80.5. Now here's the big question, is which graphic do we use? So I'm going to ask you a mathematical question. You ready? I'm going to give you a conditional distribution. I want you to put the mathematics in the chat. You ready? Of the days it rained, what percent of time was the forecast correct? So Sydney, of the days it rained, what percent of the time was the forecast correct? So of the days it rained, on only the days it rained, what percent of the time was the forecast correct? Not that this is the right answer. Of the days it rained, what percent of the time was the forecast correct? Show me the mathematics in the chat and then we'll solve it. Of the days it rained, for days that it rained, what percent of the time was the forecast correct? That's what this means. For the days it rained, conditional it rained, what percent of the time was the forecast correct? Of the days it rained, what percent of the time was the forecast correct? So only on days it rained, what percent of the time was the forecast correct? So what would the mathematics be for that? So only days it rained. We're saying given it rained, so given it rained, what percent of the time was the forecast correct? So how many days are we looking at? We're only focusing in on days it rained. So given it rained, what percent of the time was the forecast correct? Given it rained. So many days. Close. So we're only, so how many days did it rain? So just answer this first. You're really close, Sydney. Let's throw out some 20 points again. Sydney, you're really close. How many days did it rain? Layla, great job right there. And see, so it rained 36 days. It rained 36 days right there. It rained 36 days. And then in 29 out of those 36 days, 29 out of the 36 days, there was the forecast correct. Does that make sense? Does it make, if we only focus in on days it rained, like I'm only going to make it clear, only look at this. Only look at this right here. We're just going to block out everything out of our brain. Given it rained. Join live Kahoots. Go over speedruns. We're going to have a Kahoot tomorrow night. Oh my gosh. Oh, thank you so much, Leslie. I really appreciate that. That's really nice of you and kind of you to say. Joining the live Kahoots. Yep, we're going to have a Kahoot tomorrow night. We do $20 grand prize. No, we should do a $10 second prize, I think. And then we're just going to divide by. Don't worry about that 7. And that will equal the 80.6. So given it rained, what percent of the time was the forecast correct? And then every other percentage follows if you want to check them, but that should be it. Really doesn't appear to be much of a difference right here going on. But yeah, join the Kahoots. Do all the homeworks and the quizzes. I'm going to show Leslie something here in a second, which they've seen. No, there does not appear to be an association because the percentages are really close. And really quickly, so Leslie can see this, I ran the statistics on your guys' class, and check this out. For the people who did the work, this is from last semester, if you did basically the homeworks and the quizzes and got above a 90%, and this is almost half of the class, because we had about 300 and so students, for half of the class, they did pretty much the work. This is what I would say is doing the work, making a 90 or above on the quizzes and homeworks. Like this was their average. Like we have drops. So they didn't make a 90 or above on everything, but half of the class almost made a 90 or above on all the quizzes and homeworks. And great job, Sydney. And then what do you notice right here? 93.4% of them made a B or better. 93.4% of students who did what I would consider all the work, like all the online work, made a B or better. So Leslie's given some great advice there, which follows what I'm noticing with the trends in the data, that if you do the homework, do the quizzes, come to Kahoots probably to prepare for the test, it's going to be great. It's going to be awesome. And we'll have a Kahoot tomorrow. Yeah, we should do it tomorrow night. We'll have a Kahoot tomorrow night. My gosh. Whew. Let's see here. Let's hop back to space and do another question. So stay motivated, everyone. We're working hard, getting the work done. If you're in office hours right now, you're doing extra. You're doing great. Make an A instead to 1. I know, Leslie. I like seeing that. I like seeing that the work pays off. I like seeing you do the homework, you do the quizzes. You have a good probability of making a great grade in the class. Like, it's my gosh, it's like 70% of students make a B plus or better. 60% of students make an A or A minus. Almost 2/3 of the class makes an A or A minus by doing all the work. Now, it doesn't mean if you do all the work, you'll make an A or A minus. Maybe you're like, I don't know, maybe you have a friend doing the work. Don't have a friend do all the work. That's cheating. Don't do that. I think there was it Layla? You had one? No, I think there was one before yours, right? Everyone remind me, because we have another question. We did Sydney's question. This is why I like having chat. Does anyone see? Simran had a question. Oh yeah, Simran, could you help go over it after you answer? Yeah, Simran, if you want to put your question in the chat. Can we go over the one that says a forester measured of the trees? Is that in the homework? Mm-hmm. We can do that one right here. Please, and if we missed someone's question, I think there was another chapter 5 one. If you wanted about chapter 5, remind me again about chapter 5. Someone wanted chapter 5. I'm trying to find it. Chapter 4, quiz question. Yeah, we did. There we go. That's Sam's question we did earlier. Yep, let's do that. Cool. We're going to do that one right here. And let's check it out. I think there's so much negativity in the world, so much like just not fun things, that my goal with this class is, one, we're going to learn statistics, 2, we're going to have some fun. And yeah, that's what I hope. I hope we can learn statistics and have fun. So let's do it. Let's learn some statistics. Let's do that next right here. You got it. So we'll put it in the video for them. Quiz chapter 5, quiz part 2. I think you're right. We'll do this. We'll do your question, Layla, and then we will do chapter 5, quiz part 2. There's some questions I really like in that one. It actually has one of my favorite questions. It's one I like to guess on. It's a lot of fun. Okay, wait a minute. 68, 95, 99.7. This one's out of order. So when we do 68, 95, 99.7, it's the percent of area, or between 1 standard deviation, 2 standard deviations, 3 standard deviations. So this one's wrong because it needs to go in order. 68, 95, 99.7. They've reversed these numbers. So now we need to see the numbers right here. That's 19.2, and that, or is that 10.2? That's 10.2. I can't read. 10.2 is the mean of the distribution. You can see it up there for a moment. 10.2, the mean of the distribution. Exactly. Boom. Great job, Layla. You are correct. That is the mean of the distribution, and it follows the 68, 95, 99.7 rule. Now, the middle 95% will be within plus or minus how many standard deviations, and you can see it right here. The middle 95% will be within plus or minus how many standard deviations. The middle 95% is always plus or minus this many standard deviations, which means we would go up 4.3, up 4.3, down 4.3, down 4.3. It's within a span of 4 standard deviations, but it's up 2 standard deviations and down 2 standard deviations. So it does span 4 standard deviations. That is correct. But it'll be within 2 standard deviations, spanning a length of 4 standard deviations total. Yep. Nope. So no, you are correct. It's 4 standard deviations in length, and then plus 2 minus 2. Yeah. No, that's a good answer right there. And then we're just going to go take this 1.6 right here and that 18.8 right here. So that is 1.6 and 18.8. Once we get around to it, I don't understand what a question on the quiz is asking. Yeah, which one is it? Sam, copy paste in the chat, and we will do that. So I need to tell Chelsea about Orange too, about the show. We need to check this anime out. We got to finish Attack on Titan AOT. Using the 68, 95, 99% rule, what percentage trees should have diameters below 1.6? Okay, let's do the inside-outside trick. You ready? I need to move my camera for this. Maybe I can set this up for tomorrow. Okay. Yeah, good question right there. So how much area is Brian holding in his hands right here? I need to not mirror myself. How much area is Brian holding in his hands? How much area is Brian holding in his hands? It's never worked. I might never do this example again because it's never worked so well. How much area? 95. How much is outside my hands? It worked when I do this in class. This is one of those things that just doesn't work as well online, because now outside of 95 is what? It's better when I draw it, probably. It's way better when I draw it. Here, I'll draw it. Gotta remember, not everything that works in class translates to online. So works better online when I go over here and I say, let's take a look at this. And we go right here and we say 95 in the middle. If 95 is in the middle, then what percent is total outside? What percent is Layla, you're getting it. Great job. Layla's got the answer right there. Layla said total outside is 5%. So I'm going to highlight that in green so you can just see it's 5% total. Like both green arrows added up are 5% because in the middle is 95%. If you can't see this, it's 95 right there. And that makes 2.5 on either side. And that is going to be the answer. Good test questions right here. Like using the empirical rule, which we can always use to figure out answers. 2.5 have diameters below. And make sure it's below. If it was above, it'd be 97.5. So now we want to go between 14.5 and 18.8. Now 14.5 and 18.8, if you turn those into z-scores, 14.5 and 18.8 are going to be a z-score of 1 and 2. You can see it right there, 1 and 2. And so now we can actually use this to our advantage. We've got the 2.5 that we got earlier, and this is very similar to a previous problem we solved. In the previous problem, we said, what percent of area is between here? What is one of these arrows worth? What is one of these arrows worth over here? What is one of these arrows? This is the same trick. So what is one of those green arrows worth? One of those new green arrows that I just drew. So this is 68%. What is one of those green arrows worth? What is one of those green arrows worth? We're interested in this area right here. That's what we're interested in. That's what we want to find. 16, great job. So if that's worth 16, we only really need the 1. We're only focusing on the area between. We're only focusing on this blue area. So what do you think? Oh, Simran, you got it. I think yours was next, Simran. So what do you think this area will be worth right here? Because 2.5 is above here. 16% is above here. So if you were to take and subtract off this 2.5 off the 16, which is the area above here, then what is that blue area worth? Because 16 is the area total across 13.5. And we have another document open. I might have to go grab that picture again. Let me go over here and take the picture. There it is. We have a document, just so if anyone's looking at this question, because I know sometimes with the timestamps, we've got this picture right here, which I'll show during class 2, that shows all the areas. So you can actually get all the areas. I do think you should practice solving for them, but I'll zoom in on this so you can see. If you want to take a picture on the screen, let me jump off the screen. I think it removes me. Good, I'm gone. So if you can't find this graphic online, here it is in the picture for you to see. So the answer is going to be, for this one right here, it's going to be 13.5. Oh, wait, and it was yours. What if it's between? Yes, I think you, yep. You got it, Layla. That'd be right. Do you see how you just divide it? You are correct. Great job, Layla. Does that make sense? And then we'll do Simran's next, I believe. Does that make sense, Layla? When you see right here, that's just half of 68. So you would do half of 68 to get that right there. So great job. You are doing it exactly correct. Half of 68. And you can see the graphic labeled right here with some of the areas we're finding. So that area right here is 13.5 right there. So you can see it. Great job. Great work. Oh my God, too many documents. So this is 13.5. And one more. Over 18 inches. Over 18 inches. So where's 18 inches at? Okay, 18.8, I think. Oh, well, we've already got that drawn in. We already solved this one by accident. Over 18 inches, 18.8 inches is 2.5. So great job. We already got the answer. Above it is 2.5, and we solved that by accident. Yay. Can we read chapter? Yep. I think that's Jessica asked that next. So Jessica, your question is next. Thank you, Jessica, for reminding us. Which part do you want to go over? Which question or two do you want to go over? We might go a little bit over off Sarah's day because so many great questions. Thank you, everybody. Who will hop to space? Jessica, you pick the question. It's Jessica's. Jessica, it's your turn to pick the question. Thank you so much for waiting. I appreciate it. Everyone is very patient and everyone is just doing a great job. I mean that. I took some classes in minis from a while ago and it's so quick. I need to stop saying that. You're like, we know, Brian, we're taking the class. It's my way of saying that I'm very proud of everybody. It's my way of saying I think it's a great achievement to finish a class in 3 weeks. What is the number one? Sure. Outliers of a box plot are blank. Oh, yeah. So outliers of a box plot are how many IQRs above or below Q3 and Q1. Who can help out? Who will help out Sam right here in this in between? Outliers in a box plot are how many IQRs above or below Q1 and Q3. So you've got here Q1, you've got here Q3, and outliers begin where? Where do those fences begin? I think I can answer. I'll show this here visually. I'll show Sam's answer. Who can help out right here? Outliers are how many IQRs above or below Q1 or Q3? Great job right here, and I'll show it right here so we can see it. Outliers are, Jessica, I've got They are 1.5 IQRs above. Yeah, no, Sam, when you see her like, oh, yeah. No, that's what we want to do. And we've got the formulas right here. So great question right there, Sam. I'm sure you helped someone out with that right here. Like you said, all it makes sense. But if you don't ask, then you don't know. And great job, Sam. We've got the visuals right here showing where Q1 and Q3 above 1.5 IQRs and below 1.5 IQRs is where outliers begin. And we draw to where our data goes to. So let's hop back. We've got this ready to go. Question number 1. Let's start question number 1, chapter 5, part 2, homework. And great job, Jessica, and everyone working ahead. This is for tomorrow, but working ahead. Make sure we understand it. Yeah, definitely. Here we go. We could do another one of these afterwards, too. You're welcome, Sam. Have a great day. So there were 53 competitors in a downhill event. Their times, their times are shown right here. The normal model with a mean of 102.96 and a standard deviation of 3.892. What percent of times? Oh, on the quiz? Yeah. Oh, this is Jessica's turn. He'll go back. All right. On the quiz. What does your first quiz question say? Because the quiz questions are different each time, Jessica. So the quiz questions are different each time. What does your quiz question say that you want help on? Because the quiz questions are different each time. So the first question on the quiz will be different for you than it is for me when I bring it up right here. What does, ooh, maybe it's this one. This is my favorite one. What does the start of your quiz say? I'm going to drink some coffee right here. So what does the start of your question say? It might be this one. I hope it's my favorite one. Does it say what percent of a standard normal model? If it does, I'll be so happy. If it doesn't, that's all right. It's my favorite question right here. Probably of all semester. And if I say that for another question, I'm sorry, question. The cholesterol levels, that's a good one too. It's not what percent of the normal model, but we'll do it. I mean, we'll do all questions. But I love the one. I love that question. What percent? We almost found it. Is it the yep. It literally, check this out. You ready? Perfect right here. Perfect help right here. So this was actually the last question. So you see there's 16 total questions that you can get, like 16 different questions you can get. And this was the last question. I kept looking. I was like, I hope it's here. When I got to question 15, I was like, I hope I can find the question. And I was like, did I miss it? Did I not read it? So we have here the empirical rule again, which tells us 68% of the data is within one standard deviation, 95 is within 2, and 99.7 is within 3. It's just telling us the concentration of data. The data is generally within about plus or minus 3 standard deviations. So we need to make sure we have 68, 95, 99.7 going out like that. And the mean of the distribution is 198. And the standard deviation is 23, which is the units up and down we go, going up and down. So like you go up 1 standard deviation, so that's 23 up. That looks to be 23, 23, 23. I think 23, 23, 23. It's just, you can't see. It's going up and down 23. That's what the standard deviations are, like 1 standard deviation up, 2 standard deviations up, 3 standard deviations up. And this is how much data we would expect between it, 99.7 according to the normal model. That looks to be correct. Let's see. This is more than 23. That's too big a standard deviation. This one is too small. It's like the person who went and ate all the porridge. This one is too small. This one was too large. And this one is just right. What percent of adults do you expect to have cholesterol levels over 220? Well, now this gets iffy because you'll notice right here, 220 is not a number on the curve, but Mubot, you doing okay?
I am Mubot.
Oh, he's going to help us today. Mubot is helping us out with the David M. Lane applet right here. So anytime you want to use the applets, Mubot can put the links in the chat. Thank you so much, Mubot. Go ahead and put the link in the chat, Mubot. If you could do that, that'd be great. Thank you, Mubot. Hey, Mubot, you're the best. So Mubot puts the link in the chat right there for us to go to the David M. Lane applet. Now we need to go ahead and put in our numbers into the applet right here. Our numbers are going to be, was it 198 and 23? I'm going to take a guess and think it was that. The numbers were 198 and 23. What? My memory actually worked? No way. So this is the David M. Lane applet. Notice that this drawing right here is the exact, like, who thinks, like, you're like, wait a minute. Like, what do you notice about this? These two things right here are the what? Like this graphic right here. So look at this graphic. Look at me. Don't look at me. Look at me. Now look at you. Look at me. Now look at you. What do you notice about these graphics? Do they? What do you notice about these graphics? What's going on with these graphics right here? They're the same exactly. So we were able to draw out the distribution. We have the distribution now drawn out for us right here. And we want to figure out what percent of cholesterol levels are over 220. Cool. That's the answer. Now, I'll pause though. And I want us to think about this for a moment. We can take a guess at this because the finishing time is, you bet, we'll do that one next year, Simran. You got it. Oh, that's some of the, yeah, Simran, we got that next. You got it. I'll do an example of it. And so with this right here, well, that's a good question. With this right here, so Layla, using the empirical rule, what percent of area is expected to be above 1 standard deviation? Do you remember from the empirical rule? I'll draw on this. You ready? So using the empirical rule, what percent of area would you expect to be above 1 standard deviation? So here's the hint, and let's see if we can then guess what the answer is going to be close to. So there's 1 standard deviation. Here's the empirical rule. So what? 16%. So I want you to take a guess at what you think the shaded area is on this curve. What do you think the shaded area is on this curve, like as a decimal? I want you to take a guess, like 0 point what? And I want you to see how close you are because you can get pretty good at guessing these. What do you think the shaded area is? Like this whole area, like the whole shaded area, what do you think it is? What do you think it is? Because this is like how test questions, we got questions that are a little bit like this, or it could be like an A, B, C, D choice. What would you think it's going to be close to? I'll tell you my guess. We'll see who's closer. I'm going to throw 50 points if Layla beats my guess. I've got my guess in my head. I'm not going to tell you what it is. I'm going to put this right here as a hint for my guess. What do you think my guess is? Or what do you think? What is your guess? This is going to be really interesting. We'll see who's right. Layla says 18%. Brian says 16.8%. So who's right? Ooh, it's going to be close. 16.94%. I've been doing this a while. I'm still throwing those 50 points out. So I was able to guess within, just think about this, using the empirical rule, I was barely a thousandth away. So I used the empirical rule and I said, this is why we have the empirical rule, because I can look at that and say, a little more than 16%. So I can look at these graphics and get an idea. That's why the empirical rule exists, because you don't, I mean, you should use the applet, but I feel like I would have gotten it right. So 16.94. So we can make some good guesses on this using the empirical rule, but you need to use, oh, it wants here 16.9. That's as a round to 2 decimals. It is as a percent, right? There we go. What percent of adults would be between 160 and 170? So this one's going to be a lot tougher. Like this one, I don't know if I could guess this one accurately. So 160 to 170, I'm just going to do that for the second. I can draw these out, but I'm just going to use their drawing. 160 to 170. No, that's way off. Well, we do know one thing right here. We know this has to be less than what? So one thing I know is that this area right here has to be less than what? These are the numbers we saw earlier that we can get from the empirical rule from the 68, 95, 99.7. This area has to be less than 13.5. That's a tough guess one. Like, that's a really tough one to guess. I'm going to guess 9%. I'm just kind of going to, I don't know. It's going to be very hard to guess. But you know what? We don't have to guess it. We can just go between, and we can go between 160 and 170. How good did my picture look? I said it's 6%. That's a really tough one to guess. And my picture, maybe because my picture was not drawn accurately, but do you notice how I'm trying to draw this out and I'm trying to visualize what the applet's going to do? So I just want to make this clear. I'm not just using the applet to solve it. I can draw this, and then I can make estimates from the empirical rule. This is the practice, like to make sure you understand what's going on and how to read this graphic, because I'm actually drawing what this graphic should show. So I know what I should see over here. And I'm like, yeah, that's showing 160 to 170. Does that make sense, Layla? How to do these problems and really understand them is not just to type everything in the applet, but to draw it out yourself. Like if you have a scratch sheet of paper, try drawing it out, try shading the area and be like, okay, this is what I should see. That's what I see. That's showing me the area between 160 to 170. And this area represents 6.25% of people. So we would expect 6.25% of people to have cholesterol levels between 160 and 170. So the answer here is 6.25. These questions you don't have to do everything crazy on. If you want to find the interquartile range, the chemist, you got it, Simran. We'll do that one next. You got it. If you want to find the interquartile range, you can use the second part of the applet over here and go over here and go to 198 and 23. And with this, you can see it shows the same graphic. The interquartile range represents what percentage of the data? 50%, and is the middle 50. And there is the interquartile range. Oh, nice. No, Layla, you just solved it. Layla, 50 points. Layla 100% solved it right there. Thank you, Layla. That's exact. Layla, you're 100% right. The answer is 2.5 because it's 2 standard deviations above the mean. We can go back and take a look at it, but that is the answer. And you're doing an excellent job because you went 2 standard deviations above the mean. Some of these we can solve by using the empirical rule, like that one right there. Some of these we have to use the applet for. So if you notice right here, the applet gives us the answer of the lower quartile, the 25th percentile, and the upper. We could do it in quartile terms by going here and doing this for the lower quartile and this for the upper quartile, but it makes more sense sometimes to just put in the middle 50% and go between right here for 182.487. And what numbers does it want for this? The IQR, so we need to subtract those numbers. So subtracting these numbers right here, Q3 minus Q1. No, I'm going to make an error. I hope I don't have any errors on this. There's the IQR. Round to the nearest integer. Oh, well, that's no fun. Oh, wait, that's not the... And then it wants the highest 15%. So when we get a percent, we have to go to the applet right here. And which of these looks correct for the highest 15%, Layla? Above, below, between, or outside? Which of these looks correct? For the highest 15%, would it be above, the highest 15%, below, the highest 15%, between, or outside? Which of these looks like the highest 15% of cholesterol levels? And then you might notice something when you look at it, the highest 15%. The highest 15% of cholesterol levels is which choice right here when we talk about let's shade 15% of the curve. So this shades 15%, the bottom 15%. It's going to be above. That's the highest 15%. And what do you... No, you are correct. You are correct. That's above is the highest 15% because only 15% of people have a cholesterol level above this. Yep, Simran. And we can go... I can still go over that here in a moment if you want. Great job, Layla. What do you notice here? The highest 15%... I'll solve the whole thing, Simran. I'll go over it. The highest 15% is just above what? The highest 15% is just above a z-score of what? The highest 15%, because that's where that line is at. The highest 15% is just above a what? A z-score of 1. Because at 1, 16% is above. So the highest 15% is just above a z-score of 1. There's where the lowest 16% is. Is it starting to make sense, Layla, as we keep doing examples of this, to be like, oh, the highest 15% would be just above a z-score of 1, so it's like 222 or 223. It's probably closer to 223. My guess would be 223, and it's 222. I should have went with 222 because it's just above a z-score of 1. So if you're following along with that and you're able to make some decent educated guesses and you get 100 like I did, whoa, I got scared there. Let's look at Simran's question right here. Here we'll hop to space. Okay, let's take a look. Simran's question is the finishing times. Let's drop it in. Okay, I'll put for the main screen. So here we are with a Canvas content quiz question. We've got here. The finishing times of a local race follow a normally distributed data set. So they're normally distributed. Normally distributed with a mean of 25 and a standard deviation of 3 minutes. So when we say it's normally distributed, that's capital N, and the mean right here is going to be mu, and the standard deviation is going to be sigma. So there we go. So we can draw normally distributed with a mean, and that's what this is going to be right here. And so that means normally distributed with a mean of 25 and a standard deviation of 3. So that's what I'm about to draw on the screen. I'm about to draw a distribution that is normal with a mean of 25 and a standard deviation of 3. So let's go ahead and draw that right here. So we go ahead and we draw our normal curve. That's what this is going to represent right here. So that represents the shape of the curve. And then we'll do green for the mean. The mean is going to be the center of the curve. No. There we go. And so the mean will go here at the center at 25. That'll be the mean. And then the standard deviation we'll do in blue. And so when you see the standard deviation right here, the standard deviation is going to be the units. Is it a dog or something else? The standard deviation is going to be the units that this goes up and down each time. So the standard deviations, I don't like that line right there. There we go, much better. So the standard deviation is the units that this goes up and down each time we move one standard deviation. So the standard deviation here is 3. So you just go up and down 3 each time. We'll go ahead and do this. So this is how we draw the normal curve right here. We just go up and down. And an important thing I like to do right here is I like to make sure we draw the full thing in context. And this is really good practice right here. When we do this, we need to put below it the numbers that are the context. So we're going to go 28, 31, 34, and then 22. We're just going down z-scores right now, down a standard deviation each time. And then we're going to go right here and go 19, and we'll go here to 16. And then we put here 0, 1, 2, 3, -1, -2, -3. These numbers I'm putting below it are what's. These numbers I'm putting below it are what's. It looks too much like the blue there. These numbers I'm putting below it are the what's for the data. These numbers I'm putting below it are what's. All of these numbers right here are what's. These are the what's for the data. Yeah, Simran, we'll do the next question here in a moment. What are all those numbers? All these numbers I just put below the data is what? Those are z-scores. Yep, that's just how many standard deviations something is above or below. And look where 31 minutes is at. 31 minutes is right at 2 standard deviations. So with 31 minutes, great job, Leslie. Leslie's practicing right here. I love it. So with 31 minutes being right here, 31 minutes is right at 2. And let's go down here to 19 minutes. Is at -2. So what percent of area would you expect to be between here and here? Who knows the number from the 68? 99.7. I skipped a number on purpose. 68. Something, something. 99.7. What number am I missing? So 68 is between -1 and 1. Some number there. 99.7 between there. The answer is 95. So what would be above here which is the question we're looking for. Great job, Les. Yes, Leslie. Practice right there. Great job. So, everyone, what would this arrow be right here? What would this arrow be above here? If 95% is between here, we'll remove the 68. We're just removing the extra info we don't need right now. If 95% is between -2 and 2, because this is what we memorized, 68, 95, 99.7, then what would be above a z-score of 2? What would be above here? Close, Layla, close. You're so close, Layla. You're really close. I think you're doing the additional step I usually appeal to do, because I usually ask, what is the total outside? Like I usually say, first we figure out the total. So you're probably doing the step where I say, like, let's do total outside, and then let's do 1/2, because a lot of times I'll do that step when we first do it. Yep. So total outside is 5%, but then right here is 2.5%, because 2.5 on either side. Simran, is this making more sense right here? Do you see it visually like this? This is like the full complete solve of it. So I hope it's making more sense to see it all disappear again so I don't block it. But hopefully this makes sense right here to see it drawn out visually with all the notation to say that we would expect 2.5% of individuals to have a time greater than 31 minutes for the race. You could do other questions like what percent of people do we expect to have greater than 28 minutes? And that'd be 16 because it's at 1 standard deviation. So there's a lot of questions that can come from this sort of Canvas content question. But really good stuff right there. And I think Simran had another one. What else were you wondering about here? I'll reappear. But hopefully that's a full solve. That's the completionist version of the question right there. What other questions are there? Put on a little music right here. What other questions are there? Let me know. Which ones you working on? What questions are there? I think Simran had... Yeah, which one do you want to do, Layla? Sure, we just did one from Simran, so we'll do a different one right here. Which one do you want to do from Chapter 5? I think we still have Chapter 5 open, right? Which one do you want to work from Chapter 5? Your call. We'll definitely be doing a ton of those tomorrow, too, because Chapter 5 is going to be like, woo! Chapter 5. Chapter 5 is a chapter you do not want to wait until... Don't wait till it's due. Steer weights. Let's do the steer weights problem. Chapter 5 is one you do not want to start at 10 p.m. If you start Chapter 5 at 10 p.m., you're going to be like, I don't know how to do this. And you're like, well, don't start. You're doing exactly the right thing by starting now. Let's take a look at the steer weights problem. Let's do this. Okay, here we go. We got the normal model for steer weights. What site do you think we're going to go to right now, since we are going to do this via the exact calculations? Great job, Simran. So we're going to go right here to the David M. Lane applet. Mubot, help us out right here. Mubot, where you at? Where you at? Mubot, you going to tell us about David M. Lane? Mubot's going to tell us about David M. Lane. Thank you, Mubot. Here's the David M. Lane applet. You can see it in the chat. We also got the link in the chat. Anytime you see a question right here that wants you to calculate certain things and it gives you the normal model, you can use the David M. Lane. Now, a common question is, how would we do this on the test? So with this on the test, oh, you got this. Here's the one next to Simran. Yeah, good work. With this on the test right here, we would give you pictures. So you might see a picture that looks like this. This picture right here is going to show you the following. Well, let's do it easy first. We'll start out easy. This picture right here is highlighting the blank percentile of the data. What percentile on the normal curve is being highlighted right here? Because it's the top 10%. So what percentile on the normal curve is being highlighted? I'm treating this like it's a test question, like I show you this picture on the test and you have to use it. So what percentile on the normal curve is being highlighted right here? This is the what percentile. And this is what we call the standard normal curve because it has z-scores on it. So what could you do in the mean is 70 with 70? Yep, that is correct, Simran. Great job. That is correct. Thank you, Layla, too. That is correct. So what percentile is this? That's the top 10%. Great job, Layla. So 20 points. Everyone helping each other out. What percentile is this on the curve? What percentile is this on the curve? What percentile is this? So percentile is the area below it. So if you're wondering what is a percentile, Brian, The area below something is the percentile. So maybe that'll help right there. What is the percentile? Which now basically we have the answer on the screen. Remember, the percentile is the area below something, like you want to score in the top maybe 10% on a test. So you'd be at the what percentile if you were in the top 10%. It would be above the blank percentile if you're in the top 10%. So where does the top 10% start? It's at the blank percentile. The top 10% would be at the what percentile? The top 10%. So when we talk about percentile, it's area below something. So the top 10% is also known as the what percentile? What would be the top 10%? It'd be the blank percentile. Like, I'm in the top 10% of my class. That means you're at the blank percentile. Well, that means you're up in the something percentile. What would be your percentile? No one knows. I might say the answer. Hey, what's up, Courtney? Good to see you here. We need to do some Among Us for summer class. Maybe we'll do it like this weekend. We'll see if they want to play some Among Us. So good to see you here, Courtney. A random Courtney appears. 20 points right here. Great job, Layla. You are correct. It is the 90th percentile. So the 90th percentile is going to be the top 10%. You know what we can do? With the applet. So we could figure this out with the z-score. And the z-score tells us how many standard deviations it is above the mean. So all we do is we take the standard deviation, times it by, I agree. Courtney, do you have a favorite quote? Do you have a favorite quote for the class right now? If you want to use one of the quotes. I really haven't shown them enough of the quotes yet because we're teaching mini-term right now. And I haven't shown them enough of the quotes. 115288. So this is the answer right here. And I think we got that exact same answer. Ooh, it's carrying more decimals in the background, it looks like. Unless I didn't carry enough decimals. I think it's carrying more decimals in the background than we're carrying. Oh yeah, what math did I just do? Yep, let me show that. The math to take a z-score and turn it back in. If you find a z-score, I'll look in 2 seconds here, Simran. You want to take mean plus standard deviation times z-score equals observation. And this is a version of, it's switching around the formula from... We haven't seen enough Puppet Shark either lately. We haven't... That is one of my favorite ones too. Observation... Wait, observation minus mean. This green formula... So this is a reworking... What was it? Alexander was talking about... He was the one who got started on it from the dog. We have right here the z-score formula... And we have here the taking and reversing it. So this formula right here, Layla, do you see this formula right here is a reworking of this formula? Does that make sense? Like this formula up here that solves for y is just reworking this formula right here. So, and I think, great job, Layla. Layla, you're doing, thank you so much. I try not to get too sidetracked. I'm worried. I'm going to throw another 20 points. Layla's doing a great job. Courtney, if you want to show everyone your points, like, Courtney did really well with getting points. So this is just a reworking of the formula right here. And Courtney, I've been asking all students who swing by for advice. If you want to give advice to students right here, yeah, Layla is super helping out. So Layla, you've already, we were only 3 days in, and thank you so much for all your hard work, Layla. I want people to ace the class, and I think you're well on your way. So and you can see what the work people put in across the semester and everything. So great job. And Courtney, if you have any advice to students you want to give to speak to the students who may be watching this video, yeah, Simran, you're helping out too. Like Simran, you're doing a great job. Simran, this 20 points goes out to Simran right here for asking questions, for having us review, for checking work. This is what we need to do. Like, you know, someone might say to me, well, Brian, you solve all the questions for your students. We're just practicing. We're just practicing work. I mean, this is, how else are you supposed to learn? You do practice problems. That's how you learn. Don't be mean to me. Did say the top 20% or the bottom 20%? We can use the applet now to solve these. It's important you should practice solving them, but the applet will solve the answers. That's the bottom 20%. We'll just copy paste. Copy paste is awesome. Copy paste right here to 1 decimal. The middle 40%, well, we'll just go right here and go middle 40. These are harder to write. If you write a test question with the middle percent, it gets pretty hard between these values. So let's go ahead and take these values right here. These values are going to be 1 decimal. That rounds up. And 1 decimal. That rounds just like normal rounds. I think that's got it. I was afraid I got it wrong. Should we end with my favorite problem, everyone? My favorite chapter 5 problem. Brian's going to use no applet. We haven't done this lately. We're going to go. Courtney says, watch class live. Go to office hours if you can. Watch recorded videos. Do the homework and the quizzes. You get retries on the quizzes and you use them to help your grade. But understand too exactly. Courtney giving some A+ advice right there. Go to class. Do the work. We ran some statistics, Courtney, because we're a stats class. And literally we found out 93.4% of people who do the work, like get an 90 or above on the assignments, 93.4% of them make a B or better. Almost 50% of people who did all the work made an A. Opposed to, for just the full distribution, 25%. It almost doubles your probability of making an A by doing the work, just by virtue of like what we see. You see this is more of a bimodal distribution. I know it's bar chart technically, but it comes from a quantitative number. I know, but it's a bar chart. Say, Brian, you don't even know the things you teach. I know. I made these. But here you see the probability vastly increases to 93.4% of people, and you only have a few people making a C+ or a C. It is possible to make a C+ or a C, even by virtue of historic data. But let's do my favorite problem right here. So here we hop in. We're doing it. Favorite problem time. You know what we need for this? Got to make it happen. You know what time it is. It's time for Hackerman. Let's do this. Stat to 1 Hackerman. We're not going to use any applet right here. We're going no applet. We're going to solve this question. No applet and see how we do. Can we get a 100? It's going to be pretty tough right here. Let's make this happen. Let's do this. Now. Oh no, I hit the wrong button. I don't know my buttons. You do Mew. Okay, here we go. No applet. Well, first off, we know the area above a z of 1.15 is going to be above, and z-scores go left to right, so this is a positive. Now, this has to be less than 16%, and it's going to be somewhere between 16% and 10%. That's a tough one. That's a tough one. It's between 16 and 10% because I know some other numbers you don't know. I know 1.28. The percentages fall off quicker. So it's closer to about 12.2%. This is a very tough one. I don't know if I'm going to get that one. Gotta have faith, everybody. Oh, man, it's giving all these tough questions. These are tough ones. Less than 0.85. Less than 0.85 is going to be less than 0.85, which is here. You can see that it's more than 50%. I'll vanish for a moment. That's going to be less than 84%, because 84% will be below a z-score of 1. But it has to be greater than 75%. So it's between 75 and 84, because I know where the interquartile range is at. Is at the z-score of 0.67. So it's almost 2/3. Interesting. Percentiles fall off quicker. So it's between 75 to 84%. Gosh, these are hard ones today. I don't know if I'm going to get any of these right now. Oh, man, I'm scared. I'm scared, everyone. I can get this one a lot. I can get these with... I've aced this before. Gotta have faith, right? Gotta have faith. So let's go point. It falls off quicker. Or it's going to... Oh, no. Let's go 0.8 or 81.5%. Between negative... It's giving like the hardest ones possible. Between the areas right here. Between the areas of negative 0.6, well, that's going to be 34. And that's almost another 25%, but not quite. So 34 plus 21% is going to be 34 plus 21. We'll see how close I got in a moment here. This is fun for me right here. This is my fun of the day. You're like, Brian, you have fun doing this? Yes, I do. So 34 plus 21. So now I can't do simple math in my head. 34 plus 21 is 65, right? Tell me if I get it wrong. 65.2. We got the right decimal in there. 2 decimal places. Outside a z-score of this, or outside, it's outside of it. So that's more than 32%. So that's going to be about 36.8%. I don't know if I got a single one. I'll be happy if I got a single one. Oh my gosh. Oh no, I only got one of them because half of them are the multiple choices. I got one of them correct. Let's see how close I was. You ready? To see how close I was, we're actually going to solve them now using the David M. Lane and see right here that we're using z-scores. So using the z-scores, all we're going to do is plug in the z-scores, and it actually goes in this order. So the order it goes in is the first one's greater than. So we just go here and go above 1.15, and the answer is 12.15. Is that the one I got? Is that the only one I got? 12 point, and I did, it's 12.15? 12.51. I was pretty close on that one. That was the only one I felt confident on. Did I get that one? Ooh, I got another one, it looks like. So I'm shocked. The area less than 0.85. So now we're going to go less than 0.85, which we're going to go below. And we'll go less than 0.85 and 80.23. Ooh, I think that guess was way off. Oh, no. Not horrible. You can see my guess right there. There was my guess. And 80.23 is the right answer. So a decent guess. I was within about 1% there. Not horrible. Does that get that correct? That is correct right there. And then there should only, I got one of these right. I am shocked. Was it this one? I felt more confident in this one. This is the area between negative 0.6 and 1. So the area between negative 0.6 and 1 is 56. Ooh, that was my worst one. 56.74. And if you notice, the graphics should look like that. Oh my gosh. I added wrong in my head. I said 21 plus something, plus 34. Yeah, 21 plus 34 is 55. So technically, I should have done, I just added it wrong. If you review the tape, I should have gotten that with my guess. But the correct answer is going to be this. That means I got the last one right. 56.71. This is my fun right here. And then I got the last one right. Wow. Well, that makes me very happy that I guessed the last one correctly. Yeah, do you want me to solve this one for real, Layla? I can solve this one for real. Do you want me to do another version of this and solve it for real and show you like just how to normally do it? Like we can just do it completely normal. Would you want me to do that real quick? Would it spend time a bit longer? Oh no, you might have put it in there. Make sure there's a space next to the error. I'm making so many errors. But I did get this one correct right here, it looks like. So the outside right here. Yeah, let's do it. You're always free to ask. Pillar. Okay, come on. Come on. I did not cheat. I got that one down to the hundreds. That's worth it right there. I think I should lose some errors because of that. I got one of them right down to the hundreds. Exactly correct. Finish my coffee for that right there. There we go. That was a little... That last one was only the one we did the Hackerman on. That was the only one right there. It was the only one. The other ones were not so much stat 2 on Hackerman. Maybe the first one. The first one was all right. Let's take a look at this for real. We'll hop back to space and people can enjoy that. Okay. Put back on the real graphics. There we go. Okay. So we'll do this problem for real this time. And when you do this problem, I think it works too. We already checked it. Can I get another version of it? Okay. 2 seconds. I'm going to have to reload the quiz. I consulted Puppet Shark and he said, no, Brian. Have you talked to Tiny Puppet Shark? Here's what Tiny Puppet Shark has to say about that. That's regular Puppet Shark and Tiny Puppet Shark. They both agree with me. So I have never heard Puppet Shark say no. So I reject that. I reject that. There's a low p-value on that one. We'll go right here. We'll do another version of it. And we'll be serious this time. We'll put on our serious face. But now it gives me one I can guess. Why is it going to do that? Okay, let's hop over here and let's take a look and be serious on this question. Here we go. Serious face time. Okay. This problem right here is using the standard normal curve. What do I mean by the standard normal curve? Everything on this curve will be what's. So a good review of the standard normal curve is everything on the standard normal curve, and I'll put it here in the chat for you to see. Everything on the standard normal curve is a what? You should know this when we say the standard normal curve, it has a mean of 0 and a standard deviation of 1. So everything on this standard normal curve is a what? Because it has a mean of 0 and a standard deviation of 1. Everything on the standardized normal curve is a what? So this is the standard normal curve where it has a mean of 0, which is the center of the curve. And then we have a standard deviation of 1. Everything here is a what? The standard normal curve, everything on it, you can just put one letter in the chat. The standard normal curve means every value I see, like if I put in a value right here of above, and let's say above 1, which is going to be very close to 16%, very, very close. This 1 right here represents a what? With a mean of 0 and a standard deviation of 1, z-score, z-value. Great job right there, Layla. These are all z-scores. And you'll notice as we do these problems, this will be the first problem, second problem, third problem, and fourth problem. So let's go ahead and take a look. This is the answer to the percent of area that is above a z-score of 1, which is the very first problem it asks. What percent of area is above a z-score of 1? Remember, the z-score of 1 will be on the right side, which is what we just saw in our picture. And also the area right here, we're just going to copy paste it. Easiest way to make sure we get it right. And then move the decimal over. So do it that way right here. So we copy pasted it and moved the decimal over, and that's very close to our 16% that we normally calculate, but this is a more exact calculation. It's not using the empirical rule, it's more exact. So now when we go to a z-score below, and we're talking about below 1.2, let's think 1.2 will be on the right side of the curve, so it's over here, and we're also graphing below it. So when I make my picture on the David M. Lane applet, link in the chat, we need to make sure we see it's on the right side of the curve and we're going below it. Now remember our trick. We should know that we're just going to select the second button right here and we're going to go below and take a look. The picture that we see up here at the very top now is going to look just like this picture on the screen right there, the one I've chosen. If you don't see the same picture, I'm pointing right below it right now, if you don't see the same picture on the screen right here, make sure you check your numbers and check the way you're shading. But the way you see the picture should be the way you see the picture on the David M. Lane applet. And remember, it's the second button for the second question. So right here, you can see the area, it's 88.49%, which means 88.49% of the observations will have a z-score at or below 1.2 z-scores. So we can go right here and drop that in, and there it is. Also make sure to move your decimal over, and then you'll have solved the question. Next, we go to the area between, this is a z-score between negative 0.65 to 1.6. So it's just going to do the area between, and the only one that shows an area between is this one right here, because this is saying z is greater than this, and z is less than this, or this is less than z, and z is less than this, which means z is between these numbers. This is the only one that represents z being between these numbers, and let's remember the numbers, because we're going to need to enter them in on the third button on the applet, which graphs the between. And I think this was 1.6. We'll double check our numbers, and we'll double check our graphic. So let's show this right here. Negative 1.65 and 1.6, and the graphics should look the same. So make sure your graphic uses the same. One standard deviation, exactly. You'll need right here a mean of 0 and a standard deviation of 1 to ensure their z-scores. If you don't have a mean of 0 and a standard deviation of 1, change it immediately because this makes them z-scores. Without that number right there, it won't be a z-score. It's only a z-score when the mean is 0 and the standard deviation is 1, and then now all these values here are z-scores. So the area shaded on the curve right now is 68.74%. 68.74% will be the area shaded on the curve. Now this last one looks a little bit confusing right here. The last one says z absolute value is greater than 1.8. Well, let's think for a moment. What is the absolute value of 2? And is that greater than 1.8? What is the absolute value of 2? And is that greater than 1.8? Yo, Adam, good to see you here. Good to see you here, Adam. Random Adam appears 20 points. What is the absolute value of 2? And is that greater than 1.8? What is the absolute value of 2? What is the absolute value of 2? What is the absolute... I'm so... Like, we've had so many people swing by and say, hey, I love that. What if I teach online for like another 20 years? And then people are coming by and they're like, Brian, I just had a grandkid. And I'm like, oh my God. Oh no. Getting old. I'm already old. It's 2. Then 2 would be greater than 1.8. So we need to shade above 2. And then how about negative 2? A negative 2 would have an absolute value of 2. So the absolute value of negative 2 is 2, which is greater than 1.8. So we need to shade like this because we're shading if the absolute value is greater than that. And in instances when it's outside of negative 1.8 or outside of 1.8, then the absolute value of the number would be greater than 1.8. So like greater or less than negative 1.8 is greater in terms of absolute value than 1.8. Because you just plug in here negative 2 and you get 2, so that is greater than 1.8, as in absolute value of negative 2. So we need to shade outside, and that's the key word right here. We're going to shade outside of negative 1.8. And that's the area. 7.19% of the curve will be shaded in. And as long as I haven't typed in a wrong number, we've done it. Layla, were you able to ace this question? Does it make more sense? I seriously, the first time I did it, I just did it for fun because I really love this question. I love guessing it. Let's see if I can speed run this question. It's my favorite question. So if you're watching this right now, I hope that helped out as I did it more slowly. It's my favorite question probably of all semester. I use it to check my knowledge of the empirical rule, and I like to see how close I am. I wish it showed me the right answers. When I do the homework, you know what? Let's get the homework version of it because that's my favorite one because I get multiple guesses. So give me a second right here. I'm going to look at the chat here in a moment. But I'm going to get the homework version of it up where I get multiple guesses. I like guessing. I like game shows. I think that's like maybe people who like games of chance and stuff like that kind of stuff. Oh, that's too easy. Layla, you can get this one. Layla, I want you to take a guess at this one. And if you get it wrong, I'll tell you why. You'll get really close. If you want to take a guess at this, do you see how it says this is where it's like, oh, that made it easy. This wants the probability of above a z-score of 2. So you should be thinking a number in your head. And the reason it's not going to be exactly that is the area above 2 is 95.449. That's the area above 2. So 1 minus that. And then divide that by 2. That's the answer. Which it's basically this. That's basically 2.5. It's 95.449 is the exact area. So that'll be the answer to that one, which is basically 2.5. 68, 95, 99.7 is estimates of the area. And just to explain, that'll be the right answer. I'd be shocked if it's not. That's where I said sometimes it just gives me one that I know, because the area between -2 and +2 is 95.449. But we just call this 95. That's why we say 95. And then 68.26 is 68, like more decimal places, 68.27. And then 99.7300. I think it's 2 zeros after that, 99.730. But we say 68, 95, 99.7. And that's the percent of areas. So I use a lot of these numbers in my head when I'm calculating it. And I know some extra decimals that you're not meant to memorize. You're meant to memorize 68, 95, 99.7 for this class. The area below is z-score of 1.75. So that's going to be this area right here. If you can't see, that's going to be that area right there. We've got one correct. Yeah, does that make sense why I was able to guess basically about 2.5? Like, I'm like, oh, it's about 2.5%. That was a easier one to guess. This one's a little bit more difficult. It's going to be less than 97.5% because that's below 2. 1.96. 1.645 is the, my brain's breaking, is the 90th percentile. So this is going to be between 95, it's going to be between 95 and 97.5%. This has to be between 95 and 97.5%. So it's between 95 and 97.5. And it's probably going to be about, this is a tough one to guess. No. We're close. Oh, I get one last guess. Oh, no. Look at that. We were probably within close to the plus or minus. Very close to that. I could have said it's about 96%. I should have just said it's 96%. But that was my guess right there in my head. So this is me trying to calculate it in my head. And I was within just a few tenth and 500ths. So pretty good guess on that one. I feel good about that guess. Let's see how we do it. This one's more difficult. I do know the answer to this, though. This is the 95% or 1.96 is basically a 95% confidence interval. That's 47.5%. This is a little less than 25%, so that's about 23%. So it's going to fall off quicker. 21% plus 90, 47. This is a tougher one. There we go. 68.2%, which has nothing to do with the 68. That has nothing to do with the 68 we normally talk about. And this is between there, so we need to do the between. So that should be it. That's the between. And this is a tougher one to guess. I'll be shocked if we get this. It'd be amazing, but nope. And then I'm just going to move the decimal around a little bit. It's close, but it's... And then last guess right here. Oh, these are good guesses. I'm very happy. I'm within just the decimals of it, 68%. So pretty good guess right there, 68% for that one. This one right here is greater than a z-score of 1.6. So greater than a z-score of 1.6 is going to be outside in terms of absolute value. And this one right here is close to a number I know. I know 1.645 is a 90% confidence roll. So this is going to have a little more area on the outside. I know. I love doing this guessing game. It's one of my favorite things. Like, this is between 10 to 20%, probably closer to 10%. The area is going to build up faster. No, are we going to seriously be decimals off again? That was the furthest off we were. That was yeah, so we were about, it was, I should have just guessed 11%. I could have gotten that if I guessed 11. Yeah, it's fun to guess these. This one's gonna be easier to guess, 1.2818. So I'm gonna just do one last version, then I'll head off right here. I want to get 100 on it. I've gotten 100 by not using the applet. This one's easy enough to guess though. 1.2818 is a number I know. So that's the 10%. So this has to be a little more than 10%. So that has to be like 10.43%. Sure. Oh no. Am I just gonna get everything wrong by decimals? It has to be. Am I 1.2816? Got it. I was like, it has to be near that. A z-score less than 1 point. This one is one that you can maybe get close to because this is going to be a little bit more than 84%. So this is going to be like 88 for... There we go. Oh, why are we so close but missing them? Oh, last guess right here. Got it. We're getting all these on the final guess. We got 3 guesses, all we can do. Between -1 and 1.2. Okay, so between -1 and 1.2 is 68%. This is a little more than 68. That's an additional... This is going to be hard to figure out for a second right here. It's my last version of this. Okay, so 68. I know this is an 80%, but no, that has to be about 80% minus 68 divided by 2. So it's a little bit less than that. So it has to be 68 plus about 4.8. So it's 68 plus about 4.8. Okay, so 68 plus about 4.8. 68 plus about 4.8. No, this is going to be the one that loses the streak. Woo! We're doing this no applet. And this is the barrier to finishing with no applet. A really tough one. The area outside of this. This is it. Can we do it? Drum roll, please. Got 3 guesses. Can we get 100 on this homework without the applet? Okay, so it has to be between 50% and 32%. The reason I know that is because I know the IQR number. The percentages fall off quicker. So it has to be closer to 32 because it's about halfway between them. So it's going to be closer to 32. 50 and 32 have 18 between them. That's 9. So 41's the middle ground. So 37. This is it. The streak's going to be over. This is it. Layla, what number should I put in? Thank you so much, Courtney. Good seeing you. If anyone's still here, what number should I put in? Oh, no. Layla, can you... Here, wait, Layla. Can you help us out? Can you maybe save the stream? Oh, no. The stream just blipped also. That's too much pressure. So I need you to go to the David M. Lane applet. I need you to go to the David M. Lane applet. You're back now. Yeah, the stream. I promise I didn't cheat. Watch this be the right answer. So we need to find the area outside of 0.85. The area outside of 0.85. Are you able? Did you see it on the David M. Lane applet? I'm like, no, I don't want to lose the streak. Should I check it? Last try right here. No! We were so close. That last one was really tough, though. That was a good guess. It was a good guess. So we could go to the David M. Lane applet. We could do the area outside of negative 0.85 and 0.85. And there's the answer of 39.53. There's the answer right there. That was a pretty close guess. It was within 1%, but that was a tougher one. Yeah, it's pretty. I like doing these numbers in my head. There's a lot of numbers I know, like 1.2816, 1.6449, 1.9599, 2.3263. Anyways, yeah, there's a bunch of numbers I know that I use to solve this. You're only meant to memorize 68, 95, 99.7, just so anyone can see again, unless I'll put this as like having fun with like the empirical rule. I think it's fun. I like to guess these, and I see like each semester I try to get better at it. But the numbers you should know, I'm trying to find where we had, we have the graphics below here. Here's the numbers you should know are 68, 95, 99.7. But then you can also break it down to this right here. This is, I would suggest learning this, but 68, 99.7, 68, 95, 99.7 is a must. And what is this showing you? It's showing you the percent of area within the curve within one standard deviation. There's the 68. And we'll just put it to the standard normal curve, 68, 95, and 99.7 within three scenarios. Now, there are additional decimals, but don't worry about those. 68, and we can show it right here also. So between -1 and 1 is about 68. There we go. Between -2 and 2 is about 95, and -3 and 3 is about 99.7. We don't do the additional decimals. We just memorize 68, 95, 99.7. QQ straight enough, no outliers. Guess what, Leslie? They will be hearing that on Friday. Those are the conditions for regression. And very soon we will be doing QQ straight enough, no outliers. What's the last thing Leslie should know? And thank you so much, Leslie, and everyone for being here. We'll be learning some QQ straight enough, no outliers. And the last thing is plot doesn't thicken. So we'll be learning about that soon. Let me hop here to space. Put on a little music right here. Head off. We'll have a Kahoot tomorrow night. Great work, everybody. Good practice. If you had a question you didn't get answered today and you're seeing this video right now, swing by office hours. We will answer questions. I'll mark the videos here in just a little bit. So stay tuned for the videos to get the timestamps. You're welcome, Layla. Keep up the great work. And everyone have a great day. Enjoy yourself. Enjoy the nice weather. I'm probably going to go on a walk tonight. Catch some Pokemon. I will see everybody later. Bye for now, everybody. Bye. Bye, Puppet Shark and Tiny Puppet Shark.